Thank you, Grazia. And slight change in what I'm going to present, but in any case, I think it will be relevant. So I'm going to talk about individual participant data analysis as compared to aggregate data analysis as using meta-analysis techniques. So when you do a meta-analysis of IPD data, you're actually getting the raw individual level data from each study and then synthesizing it for the outcomes. And you can model the individual risk status across, therefore, hundreds of patients typically from all the RCTs, in contrast to aggregate data meta-analysis, which can only model the proportion of high-risk patients across a relatively few studies. So that increases the power to detect clinically important differences and allows you to correct for multiple important confounding factors. And so it gives the opportunity to possibly have a slightly more personalized approach. So I'm going to give you two examples. I decided to not do the ILM peel size, which is very interesting, but I'm actually going to do an IPD we've just completed on face-down positioning with Varun, which is complementary to his talk. And I'm also going to present briefly an IPD we did on the effects of symptom duration on macular hole surgery outcomes, which is relevant to publicly funded healthcare systems. So this paper is in preparation, and again, Varun's one of the authors, so thank you very much. And I'd like to thank my co-authors who've done a lot of work. So Varun's just presented his meta-analysis, which was basically slightly unclear, very well methodologically done, but we still got a slightly unclear outcome. So we updated the systematic review. We found 8 eligible RCTs, and we managed to get the individual participant data from 5 of those RCTs, and pooling them, that was 379 patients with 379 eyes. So these are the RCTs we found, and one of the nice things about it was that they had some similarities in trial design. They all used C3F8. They all had the same control arm, which importantly was face-forward positioning and avoiding supine positioning, and they all did ILM peeling. They had a variability in the number of days of face-down positioning advised, which I'll come back to. The IPD where we couldn't get the data from are these ones. So one of them was legally not allowed to share the data, and the other 2 we couldn't contact the co-authors. Interestingly, they did have variable gases used, which would have confounded our analysis, and one study didn't peel the ILM, which would have also confounded it, but we couldn't get the IPD, so we haven't included them. And also, another nice thing about the 5 studies that we did get the IPD for was that they all had low risk of bias by the ROB2 assessment method. So we did a multi-level logistic regression model to look at the effect of posturing, that should be, on primary closure and visual acuity at 6 months. And we adjusted for a number of variables. So these are the results. So 379 eyes. So for anatomical closure, the risk ratio was 1.05. Now, if you remember, that was identical to what Varun found with the aggregate data meta-analysis. But our confidence intervals were tighter, and therefore it was significant. And the number needed to treat overall was 17. So a small effect, but significant. And the grade certainty of evidence we judged as being high on that. For postoperative visual acuity, again, interestingly, if you look at our, there was a benefit from face-down positioning of the 0.08 logMAR, so about 4 letters, which was again identical to the aggregate meta-analysis, but was significant. So our confidence intervals were all beneficial above 0. And again, significant. We judged the level of evidence, this is preliminary, but we think probably low. Possibly moderate, but probably low. It's still being debated. And then we also looked at the size threshold for face-down positioning. And we did these nice graphs. Nick, my fellow at the moment, did these very nice graphs with regression models with the treatment covariate interactions included. And the gray areas are the 95% confidence intervals. So we see there's a non-linear pattern, but you can see that the relative advantages of face-down positioning do start at about 400 microns, and they reach their peak effect at 550 microns, where the risk ratio increases to 1.20. And even if you look at 400 microns, the numbers needed to treat is reduced down to 13 from 17. So getting a slightly more benefit, but still a relatively marginal effect. And this was the Eisman classification, was high. What about posturing duration? Well, we had 3 days, 5 days, and 10 days. And overall, you can see there's not a massive difference for anatomical closure and visual acuity. But I think it's fair to say that the results seem to level out at around about 5 days. So you got some benefit in terms of visual acuity from 3 days, but there was a leveling out of effect at 5 days. So 5 days is probably enough. 3 days may give you some benefit, but 5 days is probably virtually where you reach your peak. And the Iceman grade is moderate for that. So in conclusion from this part of the presentation, there's no benefit in recommending face-down positioning in holes less than 400 microns with C3F8. But after that, there are closure and probably visual benefits. And it seems to plateau out at about 5 days of positioning. And I'd love to debate the possible mechanism, because I kind of have a totally different theory involving the Marangoni effect, which we can maybe discuss. So just to go on to symptom duration now and macular hole outcomes, and I'd like to thank Naomi. Naomi Lewis is in the audience. Thank you very much for your help with this, Naomi, who's done it. Of course, Naomi did the IPD analysis on ILM peeling, which was so important in our surgical decision-making. So this came into highlight at COVID. So in the UK, macular hole surgery was classified as routine and therefore couldn't be done in many centres. And there were waits of up to 2 years in the UK, currently still, for macular hole surgery. So it's a big issue for us. So what's the effect of duration? Because the evidence is lacking. There's no RCT or high-quality prospective observational data addressing the question. Some studies have found an association, like the Beaver study. Others haven't. And there's no evidence to make resource prioritization decisions for people who have to fund these things. And I was interested to find out, was there a threshold of duration where it became less or more important, and is it independent of the risk in the increase in hole size we observe with macular holes? So we did a systematic review to identify eligible RTTs where the duration had been recorded. We found 20. We got IPD from 12 of them and pooled them, giving 941 patients. We then did a multi-level analysis, again, including similar variables as in the face-down positioning one. We found a significant effect of duration on closure, which was equivalent to around about 10 micron increase in macular hole size, which gives you some idea of effect size, and it was linear. We also found a similar effect on postoperative visual acuity, which had a bigger effect of around about 50 microns in hole size. So that's becoming more clinically relevant, that it improves your visual outcome more. And the risk of bias scores were mixed, some low and some moderate, so we graded the evidence as moderate overall, so we were moderately certain. So in conclusion, duration probably affects both closure and visual acuity outcome, but there's no set cutoff point. But we should certainly streamline surgery, and we're hoping to include this in the currently being put together Royal College and New Retina guidelines on macular hole surgery, some recommendations on timing of surgery, which will hopefully be applicable across Europe and the UK. So I'd like to acknowledge my co-authors, particularly Naomi Lewis, Baron Chowdhury, and David Yorston, and all the excellent colleagues who have helped with this, and of course all the RCT authors and participants. Thank you very much for listening.
Thank you very much, David. We have, unfortunately, time only for a very quick last comment about the methodology.
So that, again, was great. And what you saw there was the kind of sister approach to the aggregate level meta-analysis, systematic review and meta-analysis, where you take the overall data from each study and put them together. Here, what David and his colleagues had done was got the individual data from each of the studies and then federated those into a database. And methodologically, there's no question at all that is potentially a much superior approach. My only concerns are it is a really enormous amount of work federating all of those trials. In this particular case, there was half a dozen trials, but often you'll see these individual patient data meta-analyses where there's upwards of 100, 200 studies having to be brought together. And there is an active issue about, do you actually learn more from that, putting in several years hard labor, than you do from just the quick and dirty estimation. But again, a very good point. And I have to point out that the statistician that worked on that is a colleague of mine from Aberdeen, and he's also the European Scrabble champion. So if we ever wanted to get an acronym for one of our trials, it was Neil that we went to see. Just thought I'd give him credit for that.
Thank you.
Thank you. Thank you very much. We would really like to have more time to discuss all these things for the next session. But anyway, I would like to thank you all, the speaker. It was really a very interesting session, and you for your attention. Thank you very much.
Thank you. Merci.